Okay, Assalamualaikum. Welcome to the last chapter of assembly language. We are on topic 10, test and compare instruction. Okay. So let's discuss test instruction first. Okay. So basically, test instruction, it will try to end the value that we're going to test between the register we're going to test. Okay. It will perform an implied AND operation between each pair of matching bit into operand, okay, and set the flag accordingly. Okay, so if the value is the same, okay, the zero flag is going to be set as 0. If it's not the same, of course it's going to be 0. Okay, later we're going to discuss why. Okay, so that does not modify the destination operand. That means doesn't affect anything. Just going to affect the flag. Okay, the zero flag is particularly very valuable to find out if individual bits is and operand are set. Okay. So how does this happen? Okay. So let's say, okay. So the example given here is, okay, so we move the value of this one. Okay. So the example given is move value of AL with 11H. Okay. 11H, which is equal to, okay, 11H is actually equal to F 16, okay, 16 plus 1, so 17. And one second, 17 in decimal. Okay. Okay. And then AL, BL, okay, with the value of 18. Okay. So 18 in hex. Okay. How about we do it here instead of there? Okay, let's call this one first. We will move to this example later. Okay, sorry. Okay, so let's try to emulate this one first. Let's see what's the value. Okay. So the first one is the value of the x. Let's confirm it. We're going to set 17. Okay, no problem there. And then dx, it is dx going to get the value of 136. Okay, so this is 136. So from here we can see that both numbers are not the same. Okay. So why the zero flag will be set to 0 or 1? Okay. Since based on this number, so why it's going to be set to 1 is because 17 in decimal is equal to 0001, okay, and 0001 in binary. And then 156 or 156, okay, in decimal, in binary is going to be equal to, okay, 10000. Okay, nice. Okay, is it correct? Let's check this one. Okay. Okay, 1000. Okay. Okay. So if we end both of these equations, okay, we end, we try to end this equation. So what we will get here is, okay, what we will get in the end. So 0 and 1 is 0, 0 and 1 is 0, 0, 0 is 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, and 0, 0 is 0. Okay, so that's the result from our AND operation. Okay. So when the AND operation is get all zero, okay, so the value, okay, of zero flag in this step, since it's not the, okay, so for that we can test here, okay, without this, okay. So let's see our flag is here, okay, so we move the value of 1188, okay, we're going to test them. Zero flag is set to 1 because they are not the same, okay. So let's say if the value is the same, okay, so let's say the value is the same, okay. So let's say we put the value same value, okay, let's say we put 9, okay, and we compare 9, okay. Later we going to discover what is the what we call that, the decimal value of 99. Okay. Let's try to compare this one. 99 in hex is, sorry, means 150. Okay. 3 in decimal. Okay. So on this one, okay, so if we try to compare it later, okay, we try to compare it with on this new number, okay, 153 decimal and 153. Okay. So if we try to compare it, okay, 99 which will be equal to 1, sorry, 1, and here. Okay. So we can see that, okay, we're going to know what our result is. Okay. So we're going to n 1 and 1 equals to 1, 0 and 0, 0, 0 and 0, 0, 1 and 1, 1. Okay. 1 and 1, 1, 0, 0, 0, and 0, 0, 0, 1 and 1. So this on this, since there is a value, so 0, 5 is set to. Okay. So that's what will happen if the value is there. So let's try this one. Okay. Let's see what happens here. Try to emulate this one. Okay. So 99, okay, and 99. Okay. So we're going to test it. Okay. So by right, zero flag should be set at 0 because there is a value of a result of complex reason. It's just like when we do C++. Okay. So that's why in C++, okay, if you try to do string compare, especially, okay, and in C++, if you try to do string compare, it will be like this. Okay. Str y, in right, okay. Try to compare in right with in right, okay, and to check whether it's in copy. So you compare, okay, and see, okay. At the end of your what you call it condition, your output is equal to 0. So we are basically checking on this on the flag. Okay, so that's how we can relate with what we have done in C++. Okay. So as a conclusion of that, okay, so we can see that, okay, we can safely say that test is basically what we call that, test is basically is similar to, okay, if you try to compare in what we call that, okay, if you try to compare in normal programming, okay, it will be equal to equal condition. Okay. So we have larger than, less than, larger, equal, less equal. So test is suitable to be used when you try to compare equal to equal. Okay. So let's see some examples here. Okay. So let's see, we have this example. Okay. So this one, I put the value of 2 into dx, okay, and I'm going to test dx. So if jump 0. Okay, jump 0 is set, it's going to jump to lain. Okay, or if it's the same, it's just going to continue and hop. Okay, so if the value is the same, we're going to move value of ff into the x, or if it's different, we're going to move value of aa into the x. Okay, so let's try. Okay, so put one at the top first. Okay, so 1 and 2, we're going to compare. Is 1 equal to 2? Okay, so definitely not. So we assume that AA going to be pushed, going to be set into x. Okay, okay, so let's try the outlet. That's there. Okay, okay, let's try to step. Okay, sorry, I forgot to comment the previous one. Okay, comment this one. Okay, okay, so let's try to prove this one. Okay, so now the value is not the same. So by right, we are expecting AA to be set to the x. Okay, so 1 and 2, we compare. Is 1 equal to 2? Definitely not. So when it's not the same, it's going to jump to 9. Okay, that means it's not the same. If it's the same, it's just going to continue. So it's not the same. So AA will be set to the x because 0 flag is set to 0. The 0 flag is not set, so it cannot jump to. It will jump to 9. Okay. So later, okay, 0 flag going to be set to 1. Okay. So since 0 flag is going to be set to 1, so this what we call that, this instruction jump is 0 is going to be executed. So we're going to jump to 9. So AA will be set to. Okay. Okay. So now let's try again. Okay. We put the same value 2 2. Okay. Okay, so we're going to put 2 into ax, 2 into the x, we're going to compare. So it's the same value, so it's the same. It's not going to execute jump 0, because 0 flag is going to maintain the value of 1. So it's just going to continue and set the value of ff into our dx. Okay, okay, good. So now let's compare. If we put value of dx is 1 around, okay, so we're going to see that 2 and 1. So 2 and 1 is not the same. So by right, we are expecting AA. Okay, 0 flag will be set to 1. Okay, so by right, we're going to execute jump 0. So we're expecting the dx going to be set to the value of 8. Okay, I see that. Okay, so jump 0. Okay, and test is supposed to be used when you try to what you call that. We try to compare values that are equal. Okay. Alright. So now let's move to the final instruction that we need to learn that is essential for us to understand in order to manipulate the instruction we learned in chapter 8. Okay. So the next one will be compare instruction. So compare instruction CMP, okay, is similar to test. It's going to compare in the value of destination and so this is crucial for us to remember. Okay, so this also can be used to compare whether it's the same or not. Okay, so it's similar to test instruction. You still can test whether the value is same or not. Okay, so you don't need to use test. Okay, basically you just need to use good to know test. Okay, but compare can also be used to compare the value of the okay, and then it also can compare larger or equal. Okay, that's all. Okay, okay. So this is an example here. Okay, so let's try this one. Okay, we can try it. So if we move the x with this one and compare with A2, of course it's not the same. Okay, so AH is 4. Okay, so 4 is larger than 2. Okay, so since 4 is larger than 2, so 0 flag is definitely going to be set as 0. Okay, and then carry flag. Okay, So carry flag going to be set. Okay. If it's larger, carry flag will be set to what you call 0. Okay. Why carry flag is set to 0? Because we can simply minus 2 with don't need to borrow. Okay. So that's the first one. Okay. So the second one you can see here. Okay. We compare the same thing. Okay. So when you compare the same thing, okay, that means let's assume this is 1000. So when you compare 1000 with 1000, okay, so in the end you're going to get 0. Okay. So when you get 0, okay, so 0 flag going to be set as 1. But there are no borrowing here. Okay. So the carry flag will be set to. Okay. So this is similar to if you are comparing equal. Okay. So now let's give it a try. Okay. So let's give it a try using this example. Okay. Okay. So what we're going to do here is similar to the previous one. Okay. So basically, you can see here. Okay. Okay, let me put a comment here. Sama. Okay. So if we try to compare this one with C++, okay, we can say that okay, this one will be equal to what we call that E ax is larger than bx. Okay. So if larger, okay, what we're going to do is we're going to jump to okay. So if ax is smaller than bx, okay, it's going to jump to okay, okay, the L is the same, jump to sum. So that's what we try to do here. Okay. Okay. Okay, good. Okay. So that's what we try to do here. So if we're going to push value of ex, and then compare. So if the result of comparison is above, okay, ax is above ex, okay, it's going to execute this one. Okay. So let's put it here. Okay. And then you can put it this one here. Oops, sorry. Okay. Copy this one. So if is one, so else if you do this one, or else you're going to do oops, okay. So help HLT is just to end the okay. So now let's try similar to the one. So if the value is 1, okay, so 1 is definitely smaller than 2. So we're going to expect it's going to execute jump below to lebih kecil. So lebih kecil 111 we will put into dx. Okay. So 1, 2, going to compare. Okay. So when we compare, carry flag is set to 1. Okay. And then 0 flag is set to 0. Okay. And then what we call that? We are expecting it to jump to the kecil. Okay. So now it's at lebih kecil, so it's going to jump straight away to lebih kecil. Okay. So it's going to push the value of 111 into. Okay. So if the value is the same, okay, so we are expecting it to straight away move AA. Okay, we're going to ignore these two jump above and jump below, and straight away go to move CX with the value of. Okay, so it's the same. Okay, so just going to continue. Okay, going to skip the A, jump above, going to skip jump below. going to straight away move value of AA into CX and then it's going to off. Okay. And then if you put that way around, okay, 2 and 1. Okay. Oh, sorry, just now, is the value the same? You can see that carry flag is set to 0 and 0 flag is set to 1. Okay. Next one, the last one. Okay. So 2 and 1. Okay, 2 and 1. So definitely is going to do 2 and 1 lebih besar. Okay. So we are expecting FFF to be pushed into. Okay. So first, okay, 1, 2 of the carry and 0. So by right, 0 flag should be set at 1. Okay. And carry flag will be set to 0. Okay. Sorry. Oh, sorry. So when you are comparing the different thing, so 0 flag going to be set to 0. Okay, the same thing. And 0 flag going to be set to 0. Carry flag will also be set to. Since there are no borrowing, so carry flag will maintain. Okay, so it's just going to jump straight away to the big. Okay, AX is lebih besar daripada AB. Okay, so it's going to run. Okay, so that is the example. So I hope so far you understand this one. Okay. So that is about test and compare instruction. So as a conclusion for our test and compare instruction, okay, we can go to our assembly English here. Okay. So from here, you can understand that okay, if you want to do this, okay, you want to do this, it will be similar to okay, okay, okay. That means it's going to be similar to if you want to do larger than, less than, or equal. Okay, or the what you call that for the statement. Okay, so if you have a different idea, okay, so that means if you just want to do this one, okay, else, okay, we're going to omit this one. Okay, so this one going to be ax larger or equal. So instead of using the what you call that, the jump above instruction, okay, we're going to use the jump above or equal instruction. Okay, so that means we're going to change it to J8. Okay, so in this instruction, there won't be any okay, jump off equal. Okay, so same goes to if you want to make another instruction. Okay. So, for example, here, okay, if you want to do the will be the last one. Okay. If you want to try to do, okay, this one will be larger, less or equal. So that means this one to be jump above, this one going to be jump below or okay. So okay, so let's try with this one. So let's try to okay, so in order for us to execute all of this, okay, what we can do is oh, no problem. Okay, okay, good stuff. Okay. Lebih kecil sama, dan ini harus lebih kecil sama, lebih besar. Itu dari lebih kecil dari there won't be any conflict. Lebih kecil lebih besar sama. I hope there won't be any error. Let's move to half so that we can continue. Or let's change half. Okay. So instead of half, jump contoh dan ciri jump contoh. So no matter which one you do, going to jump to contoh. Okay, let's put contoh dulu here. So at the end of contoh 2, instead of half, contoh so the idea is going to test all the value is the same. Okay. So the idea here you want to make sure the jump above or same is this one. Let's say you're going to do JB. Okay, jump below. So 2 is less than. Okay, 2 1. Okay, so x 1. Okay. So it's equal. We just want to make sure equal is working. So we can equal to 2 and 3. How about we change the value? Yeah, we put 1, 3 and 2. And this one. Okay. So let's try this one. Okay. Oh, sorry, wrong here. Wrong parameter. Does it mean by wrong parameter? This one. This one. This. No jump. Okay, and keep this one. This one. So we jump. That's the problem. Wrong parameter here. Okay. Let me check. Oh, I think that is this second variable. Awesome. Something wrong here. Not sure what. Solve it. So try let's comment this one first. Let's see whether the other chunk has problem or not. Okay. This one. Oh, okay. I see the problem. It doesn't have the Lego. That's why I have to only copy paste. Okay. So this one. Okay. So, okay. Now let's try this one. The first one, we're going to move the value. Okay. Oh, sorry. Jump key. Oh, forgot to put the double dot. Okay. Never need to have the double dot. Okay. So now everything is looking fine. So now let's do our select. Okay. Like that. Okay. So move AX with the value of 1, AX with the value of 2. Okay. So when we compare, AX is less than BX. So by right, we are hoping it's going to execute what we call that. Okay, it's going to execute jump below AX less than BX. Okay, so just going to go to jump above, not going to execute it, going to continue to jump below to lebih kecil. That means going to push the value of 111 into BX. Okay, that 111 into okay. And then, okay, the next one, here, okay, we're going to jump to contour 2, so we just need to continue. So AX going to be set to 3, okay, and then going to be set to 3. Okay, so since it's larger or equal, okay, JAE larger or equal, so we could expect it's going to move FFF into DX. Okay. So observe the flag. Okay. So when it is not the same and you have to borrow, okay, so 1 minus 2, okay, so basically that's the idea. 1 minus 2 you have to borrow. That means when you borrow, carry flag will be set to 1 and there will be a value, so 0 flag is set to 0. So now since it's the same, okay, so by right both flags will be set. By right carry flag will be set to 0 because you are minusing the same thing, you don't need to borrow, but the result will be 0. So 0 flag will be set to 1. Okay. So based on that, I think it should execute jump above or equal. Okay. So that means we're going to push FFF into EX. Okay. So the final one is going to jump to control figure. Okay. Then AX 5, BX 5. Okay. So when we compare this one, so by right, the same flag going to appear. Carry flag will be set to 0, 0 flag will be set to 1. Okay, but this time we're going to ignore jump above lebih besar. We're going to say we execute jump below or equal to lebih kecil atau sama. That means it's going to override the x with the value of 1, 1, 1. Okay, so that's how it works. So if you want to do tracing with this, you can do tracing with this. Everything is our Excel. Okay. Wait until it is loaded. Okay. Sorry. Sorry. And then we're going to do this one. Okay. Okay. So for looking, okay, basically this is essential for us to call that to observe our okay. Okay. So the first value okay, going to happen here is dx, okay, and then dx, and then going to execute compare. So when we execute compare, we're going to concern about our carry flag and our 0. Oh, sorry. Okay, we forgot about that. Okay. How about we just CX in case X, X, carry flag and 0. Okay. So this is how we should do. Okay. This one. Okay. This one. Okay. So the first one. Okay. Going to do this. Okay. Basically, for the first one, the x will be set to 1. Okay, the x going to be set to. So we're going to compare. Okay, so 1 minus 2 definitely going to borrow. So this one going to be set to 1. This one going to be set to 2. Okay, so when that happens, okay, the next instruction what is going to be executed is 1 is less than 2. Okay, so let's start to unit. Okay, so we are hoping that okay, that's our flag. Let's order our flag. And okay, our flag. Okay. Okay, compare. So compare carry flag is 1, 0 flag is 0. Okay. And then so it's going to execute 1 is less, so it's going to execute the big picture. Okay. So it's going to execute the big picture. That means the next instruction will be move dx with the value of 1, 1, 1. what we have here is ES going to get the value of 111. Okay. So then we just going to straight jump to control 2. Okay. So control 2 going to execute the next one. Okay. So we're going to put 3 here. We're going to put 3. Okay. We're going to do 3. So when you compare this one, okay. So by right we are expecting you don't need to borrow, so this one will be 0. Okay. But you are minusing the same thing, so the result will be. So let's observe our flag. Okay. So 3 and 3 compare, so it's going to change. Okay. So that's one right already. So it's going to execute by right equal jump above or equal. So that means we're going to move the value of what we call that f. Okay. Going to move the value of f. Okay. So tx going to get the value of. So we're going to jump to chapter 3 now. So for example number 3, so chapter 3. For chapter 3, section will be move. But this time the value is 5. So 5. 5. And the same thing. Of course, the result, the carry flag. So, what you call that? You are ending you are minusing the same thing. Okay. So the result going to be, of course, you don't need to borrow. Okay. But the result going to be, sorry, result going to be. So this one is going to skip larger than jump above. That one, so changes. It's going to execute lebih kecil atau sama. So it's going to move the value of TF again is 1. Okay. And then your program going to copy. Okay. So that's how you do. That's how you do. So I hope you understand assembly language and you can try it. Okay, using your emulator. I hope you know how to do proper tracing. Okay, and I hope you will get get used to assembly language. So that's all. Last topic, the final topic for assembly language. Topic 10. The title just now. Test and compare instruction. So that I thank you. Assalamualaikum.